Section 8.7, absolute value equations and inequalities. Just a reminder that absolute value is the distance a number is from zero, and the result is always a positive number. So no matter what I have inside the absolute value, if it's positive or negative, the answer is always positive. So what that means is, if I have something simple, like the absolute value of x equals 5, then x can either be positive 5 or x can equal negative 5. So we're going to solve an absolute value equation. The steps we're going to follow is that we're going to first isolate the absolute value. Then we're going to split into two equations, one equal to negative and one equal to positive. We'll solve each equation and we can check our answers. Example 1, part A is pretty basic. So we have that x equals 3 or x equals negative 3. So our solutions are just those two numbers, 3 or negative 3. On part B, we have to get this absolute value by itself first. Then I take my expression inside the absolute value, I drop off the absolute value part of it, and then my other equation, I make the 7 negative, and that's how you solve absolute value equations. And we solve these two equations. And we can check our answers by subbing them back in for the x. In this case, we will find that they do both work. Part C, so getting the absolute value by itself first. And then we have a negative and a positive equation. Now this is a little bit different because it was already equal to a negative. So I'm actually going to back up. I'm going to think about that for a minute. Way up here in my definition, the result is always a positive number. So I actually cannot have the absolute value equal to a negative number. Absolute value cannot equal a negative number. Since we have absolute value equaling a negative number, what that means for this particular problem is we have no solution. Now, if you did happen to solve this, if you happen to solve this problem, you would end up with numbers. You'd get x equals 4, and you'd get x equals 2. But if you checked your answers, you'd get negative 1, you'd get 1 plus 2 equals 1. Well, that doesn't work. And you'd get again 1 plus 2 equals 1. That doesn't work. So you end up getting your solutions when you check them, they don't work. Part D, we have an absolute value equal to another absolute value, but we're going to kind of use the same approach where for our first equation, we're just going to drop off the absolute values. And for our second equation, we're going to put a negative sign in front of what we're equaling. And it's important you have to use the parentheses because you're going to have to distribute the negative sign. And so I'm going to solve, I'm going to subtract x and subtract 3. So I have negative 2 equals x. And here I have to distribute. So I'm going to add 2x and subtract 1. And so this time I get those two values as my answers. For absolute value inequalities. And just as a note, the steps I have listed here are a little bit different from the textbook steps. I've tried to simplify it just a little bit. The first step is to isolate the absolute value. The second step is to split into two inequalities. On the negative inequality, make sure you flip the direction. So if it's a less than, you change to greater than or vice versa. Then we solve each inequality, graph the solution set, and write it in interval notation. And then if the original problem is one of the less thans, the answer is going to be a single interval. If the original problem is one of the greater thans, the answer is going to be the union of two intervals. So on example 2, part A, my two inequalities, I have one where I just drop off the absolute value. The other one, I switch the direction of the sign and make the 3 negative. So when I graph this, I have greater than negative 3 and less than positive 3, which is what I said up here. When it's a less than inequality, we're going to have a single interval. So my answer is just from negative 3 to positive 3. For part B, first thing I need to do is move that 1. And then I make 2 problems out of it. On the second one, I change the direction of the inequality and make it the negative. So then I solve this and solve the other one. And when I graph, I have x is less than 4 and x is greater than negative 1. And my answer is just in between them, because it was a less than for my original inequality, so it's going to be in between negative 1 and 4. Part C, my original problem is a greater than problem, so I'm going to be looking at the union of two intervals. So we have negative infinity to negative 2, union 2 to infinity. Part D, solving my inequalities. Graphing on a number line, greater than or equal to 1, less than or equal to negative 6. My original problem was a greater than, so I'm expecting to have this gap in the middle. The gap in the middle, I put a union sign.